This recording is a lesson from May 22nd, 2014. First of all, this was our whiteboard and what we turned in. Secondly, these were the announcements today. This was the do now worked out. These are the answers to part of last night's homework. The part from the worksheet passed out in class yesterday. These are the answers to the other part of last night's homework. This is the complete solution to number 8 from the problems in the textbook, and you had to use this guy to get some of your numbers. For instance, let's look where these numbers came from. 10 to the minus 1, change the sign of the exponent, and that becomes part of your pH. And this part of the pH, of course, is a log. This guy is also a log. And where did he come from? This guy here came from the chart. Okay, and it was this 5 that gave us that number. So the number in the concentration is 5, and the negative log of 5 is minus 0.7, which you see here. Negative because it's a negative log. Whenever we are going from concentration to logs, or to logarithms, to pH. There we go, finally got it out. When we're going to pH, we always have to take the negative log. See, this is the negative log of, or this is the negative log of this. Moving on. Here's the solutions for the problem 10 from the textbook. And again, this guy is coming from the exponent of the hydrogen ion concentration, which had to be figured first. And then this guy, again, comes from this. Okay? And 7 is coming because we're taking the negative log of 5, which is the other part of the hydrogen ion concentration. And so the 5 becomes 0.7, and we have to add those. And again, because this is a minus log that we did, we had to change the sign. And so now we just add the two logarithms up. See, both of these are logs. LOG. Right, both of those are logs. And again, down here, pH is a log. Okay? Not exactly like a normal number, but we treat it that way for most purposes. Here we have a weak acid, 5% ionized. This was number 6 from the homework out of the textbook. And again, the complete solution. Here's the complete solution for number 10. And here we go, things that I had people write down. You should have this list. It's a list of all of the strong acids. That's pretty easy, huh? And strong bases are very easy to recognize because any metal with a hydroxide ion is going to be a strong base. So let's look at a couple of strong bases. Calcium hydroxide. And then we have another strong base like sodium hydroxide. It could be beryllium hydroxide. I think beryllium's in column 2, so this guy's going to have 2 hydroxides. And potassium hydroxide. Any of these guys would be considered strong acids. Or strong bases, I'm sorry. Strong bases. And now let's move on. And we've got a big picture of what we've been doing and what we're about to do. So the big picture is, first of all, up to now, we have been taking concentrations of acids or bases using the minus log to get the pH or the pOH. And now what we're going to be doing, and this was today's lesson, we're going to take the pH or the pOH and we're going to take it back to concentrations of hydrogen or hydroxide ions doing an anti-log. So let's see how that works. This is a typical problem. We have given in this problem the POH, and we're supposed to find the hydroxide ion concentration. And this is truly anti-logging. And here's how it works. It's just the reverse of what we have been doing up to now. So what we're going to do is we are going to first of all take this number, the 8.32, that came from the given value of the POH. We're going to change it to the next highest number. We're not rounding. Rounding, this would become 8.0, but we're taking it to the next highest whole number. So what we're doing is, so the next highest whole number is 9.0, and we could even make that 9.00, make it a nice even number. All right, and then we're going to change the sign and make it into an exponent of 10. And that is part of the concentration. Okay, so this guy right here became an exponent of 10 when we moved it to the next highest number. Now, the actual POH is going to be less than 10 to the minus 10, or 10 to the minus 9, which is what we have here. So, why is it less? Because we are going to take the negative log of the 8.32, okay? And the negative log, or I'm sorry, we're going to subtract the 8.32 from the exponent of 10, which is 9, all right? So 9, we're subtracting this. This is going to tell us that we're 0.68 in logarithmic numbers away from 10 to the minus 9. And we are less than, which is what you're going to see work out here in just a moment. So, to anti-log, we are going to use this chart. Let's go ahead and make it big so we can read it. There we go. And to read this chart and get our numbers, we will be able to estimate that the number we have over here, the 6.8, there we go, the 6.8 is a logarithm. That's why I labeled these guys logs. Okay? Because it's a logarithm, we have to look in this column. And the 6.8 isn't here. So we estimate. Now, there's about 10 numbers between 0.6 and 0.7 if we're looking in this column, or the hundredths column. So the actual number that's going to change back to, so that it's not a logarithm anymore, is somewhere between 4 and 5. And we could call this 4.8. It doesn't have to be exact. It's not going to be exact because you can't make it exact without a complete log table. But this works just fine. Any standardized test that you take, these numbers will get you close enough that you can answer the multiple choice questions. And so this little log chart of just the numbers from 1 to 10 is very, very useful. Now you see I kept this in blue. This is part of the concentration, and this is the other part of the concentration. And you'll notice that getting this number was the reverse of the way that we went before when we were doing the minus log. Now we're doing the minus anti-log. So we put the numbers together with a times in between, and that will give us our proper concentration, which is going to be the hydroxide ion concentration is equal to 4.8 times 10 to the minus 9. Now, I'd like you to look at this example problem, because this is part of the homework that was supposed to be done last night, and just check and see if you can follow this using my prior slide as an example that will give you a little bit more input. So take a look at it, copy it down if you want, And that's all we have to say on this video. I hope you find this helpful for doing anti-logs.